This is a quick explanation to help go with the task, just to check that everyone knows exactly what happened when we did our experiment. And I fully understand if it's a bit tricky, but let's work our way through it and just check that you understand. So we had a ball here, and it had a certain kinetic energy when we threw it against the wall. That kinetic energy was dictated by half the mass times the speed squared. And so we weighed it, and we could work out half the mass, and then we calculated the speed in quite a clever way. We got a meter ruler, and we timed how long it took the ball to travel 1 meter, say, or you might have made 2 meters. And then using our speed equals distance over time triangle, we could see that the speed was how long it took to travel the distance that you chose to make it travel. And so we got the speed, and then on our calculator you just need to take that speed and square it. And so that was a clever technique to find out the kinetic energy by both speed and by halving the mass that you weighed. Now, we then need to think about what physics occurred. So when this ball hit here, it would have released some thermal energy, because, as I hope you remember, whenever two bodies collide, there is friction, and friction releases heat. So there would have been a bit of thermal energy released. And also, you probably would have heard the ball hitting the wall. So there would have been a bit of sound energy. Now, energy can't be created or destroyed. So the total energy of this ball here must equal the total energy of this ball here plus any of the thermal energy and the sound energy that came off. So actually, if thermal energy and sound energy have come off, this ball here must have a little less energy than the original ball, because it's lost some. And so, when we are looking and investigating how much energy that ball has lost, we can do it by measuring the speed back this way using the same technique of a ruler and measuring the time it takes. And so we use the same equation and we work out the new kinetic energy of the ball. Half the mass, which will be exactly the same as before because mass doesn't change, but the new speed. And so, if we were to think about this ball hitting the wall and bouncing off, we'd see that it was going slower. If it's going slower, then it must have less energy, and we work out the new speed squared times half the same mass, and we get a new value for our kinetic energy. So we can, by measuring the speed before the collision and after, work out the new kinetic energy of the ball, and therefore actually work out how much energy must have been lost as thermal energy and sound energy. Don't be scared by the equation up there, the kinetic energy equals half mass times speed squared. It's just a case of inserting the numbers that we get given. So we found out the mass, we found out the speed, and then we just plug them in. And it's no different from having, do you remember, a rectangle where you have the height times the breadth is the area, and that's no different to that formula there. That one's a little more complex. It's got things like squared, but you just still use a calculator. And if that was 5 and that was 10, you wouldn't have any problem going, oh, it's 5 times 10. Well, this is just half times the mass times the speed, and on your calculator you do squared for the speed. So that's a quick run through of what we did. We calculated the speed by distance over time, we weighed the ball, and then we plugged in the figures before and after the collision for kinetic energy being half the mass times the speed squared.